Welcome to our extremely brief two-slide lecture on changes of phase. The three main phases of matter on Earth are solid, liquid, and gas, which I have explained the difference in previous lectures. When energy is absorbed, a change of phase occurs from a solid to a liquid or liquid to a gas, or sometimes from a solid to a gas in a process called sublimation. And when energy is released, the phase change goes from gas to liquid or liquid to solid. This is because a solid has stronger chemical bonds holding the molecules together than a liquid does, and a liquid has stronger chemical bonds holding it together than a gas does. In order to break those bonds, you must introduce energy into the system. If you release energy, then there's going to be less kinetic energy, which means that the gas will coalesce into a liquid or the liquid will coalesce into a solid. The main thing we haven't gone through in previous lecture about phase changes is the fact that as you introduce heat into a system and cause there to be a phase change, there is no temperature change. Instead, as you introduce heat into a system and cause a phase change, there is no temperature change like there is if it's in the same phase. Instead, the temperature stays constant for an amount of heat which is equal to Q equals the mass times a property of the material called the latent heat, whereas the heat required to change the temperature is equal to the mass times the specific heat times delta T. This graph shows how much energy is required to heat up a sample of ice from negative 50 degrees Celsius to some temperature above 100 degrees Celsius. The amount of ice that's being heated here is going to be 1 gram, which you can tell because it takes 100 calories to go from 0 degrees Celsius to 100 degrees Celsius. And the definition of a calorie is the amount of energy that it takes to raise a gram of water 1 degree Celsius. What's also interesting about this is that this is used as one of our cooling processes. As we sweat, the temperature of our bodies will be lowered because the temperature difference will cause there to be a vaporization of the water, which is going to absorb a lot of the heat in the process of the vaporization.